Sampling rate is the number of times in a second that the computer records the amplitude of an analog signal. So if we say that the sampling rate is 2, it means that the computer only records 2 numerical values in that 1 second. As you know, EEG comprises of numerical values, and these values are connected to form a line graph. Let me give you an example. So let's try to simulate something on this Excel sheet. So here I'll create some random numbers. So what we will try to do is create random numbers between -5 and 5. So this is the first number, -2. And I'll pull it to increase the number of random numbers. So we have 3, 4, 5, 6, 7, 8, 9 random numbers here. If I plot it as a line graph, which I'm doing right here, I get these waveforms. So the waveforms that we see on the EEG is basically these data points that are connected together to form the line graph. The more the numerical value, so each of these data point represents a numerical value. So you can see that all of these are represented over here. If you have more data points in 1 second, so let's do that. Let's pull it up. If you have more data points, I'll cancel this one here, so I'll delete this graph and create a new graph. So now we have more data points, and if I graph it here using this line graph, I see more waves that are there. On the other hand, let's clear this whole thing up. On the other hand, if I only had 2 data points and I try to plot those, I'll just get a straight line. So you just get, because you're just connecting those 2 numbers. EEG comprises of numerical values, and the numerical values are exactly the same as the sampling rate. If you have to resolve EEG, the sampling rate has to be 3 times or higher of the frequency that you want to resolve. So let's say that the analog signal is that of alpha waves. Alpha waves span between 8 to 13 waves in a second. If I to resolve 8 waves, I will need a sampling rate of 24. So let's do that here. So we'll take this and we'll have more than 24 samples here, and we'll graph these samples together, and we should be able to see at least 8 waves. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is higher. So to be able to resolve alpha waves of 8 Hz, we need to have a sampling rate. So these are all the samples of at least 3 times of the frequency of interest. So in this case, a sampling rate of 24 or higher. Okay, what happens if I don't do that? So let me cancel this here, and I just take a sampling rate of 3, 4, 5, 6, 7, 8, 9, 10. So if I take a sampling rate of 10 and try to resolve alpha frequency, I get only 3 waves. So this is a delta frequency. So you get a distorted view of the waveforms. This is called aliasing. So aliasing basically means that if you do not have a sampling rate which is 3 times or higher than the frequency of interest, you may see waves which are slower in frequency than the actual analog signal. This is called aliasing, and to prevent aliasing you need to have a sufficient sampling rate on the EEG. So let's further increase it. So we are creating more samples here. So let me go all the way down now. a sampling rate, let's say, of 200 here. And if I graph all these samples together, I get a pretty high frequency here. So a sampling rate of 200 will be able to resolve a frequency of 65 or higher, 65 to 70 Hertz. So that's the point here, that's the point of the lecture, to understand what is sampling rate. So just to summarize, just to recap, sampling rate is the number of times in a second that the computer records the amplitude of an analog signal. The sampling rate has to be at least 3 times the signal that you're trying to resolve. If you do not have a sampling rate which is fast enough and which is not 3 times the analog signal, the waveforms appear distorted. You start seeing waves which are much slower than the analog signal, and this is called aliasing. That's it for today. I'll see you at the next tutorial.